Ciao, Em. So today we're going to learn about complex numbers, also known as imaginary numbers. And before we start talking about complex numbers, we're going to talk about where they come from and why do we actually have to talk about complex numbers. Okay, so first of all, let's talk about what we know so far. Equation. Look at the equation example 1 on the left. When we're asked to solve for this, if you know the graph looks like this. You graph it, you make a t-table, you graph it, and it's a parabola going down, hitting -4 and going back up. When you're solving for this, you want to find the zeros, these points where they cross the x-axis. So how do you solve for it? Where they cross the x-axis is when y is 0. So you set y to be 0 equals x squared minus 4 and solve for x. Add 4 to both sides, 4 equals x squared. Square root both sides. X equals 2 plus or minus. Remember, when you square root both sides, you have a plus or minus. And what does that tell us? That tells us it crosses the x-axis over here at +2 and over here at -2. And basically, that's what you're doing when you're solving. Now, where does imaginary come from? Where did actually the idea of imaginary actually come about? It's actually from problems like number 2. Example 2, actually, when they start talking about imaginary numbers. Let's take a look. Let's do the same thing we did for example 1. Now we're doing example 2. Same thing, find the zeros. Set y to be 0. X squared plus 4 equals 0. Solve for x. Minus 4 from both sides, -4 equals x squared. Get rid of the square, square root both sides, square root both sides. Let me write it down here actually. Square root both sides. And x equals plus or minus the square root of -4. That's kind of different. Square root of negative. If you have your calculator, get it out, please. And put that in your calculator and see what you get. And you're going to get a lot of different answers. You can get stuff like no solution, or invalid domain, or what are you doing? That doesn't work. It depends. So this actually does not work. You cannot square root a negative. You can never square root a negative. Why? What's happening in this graph that can't give me any answers? Let's take a look real fast. And we did graphing before, so you see what it looks like. Same idea. But when I graph this, and you can actually graph it by hand if you want, but I already know the answer. When you graph this, it looks like this. At 1, 2, 3, 4, and here's your parabola. So where does it cross the x-axis? It really doesn't, right? So therefore, you really don't have a solution here. So then, mathematician, scientist goes, what if I create, because real numbers, there's no real numbers that will work. There's no numbers that I could square and give me a negative. Think about it. If I put a 2 in here, square it gives me a +4. Put a -2 in here, square it, it gives me a +4. So there's really no answer that would give me this in the real field. So they go, you know what? This doesn't work, so let's make another field. Let's call it imaginary field or complex number field. And then that's where we come up with complex numbers. And let's talk about complex numbers real fast. There's 2 things you need to know about complex numbers before we actually get started. You need to know 2 things. 1, I. I, the symbol for I stands for imaginary numbers or complex numbers. Imaginary. So what's I? I just stands for imaginary. When you say 2i, that means 2 imaginary. 3i, 3 imaginary, etc., etc. I squared equals -1. Those are the 2 things you need to know. Some books still tell you this. I equals the square root of -1. That's also the same thing, right? But I like to use the first 2. I is imaginary, I squared is -1. If you know those 2, you're set to go. Now let's talk about, before we go on, before we actually do problems, the big questions, the underlying this, like, why do we even need imaginary numbers? What's the purpose of this? Why do we have to make this imaginary field and start getting answers that are not real? And why do you even call it imaginary? Before they started making this, they didn't think there's going to be any purpose for it. A long time ago, in the 1950s or something like that. And they go, there's no purpose for it, so let's call it imaginary. And later on, you found purpose for it. And let's take a look where you might use imaginary numbers in real life. So, control theory. You're going to use imaginary numbers in control theory. It's a little more complex. In fluid dynamics. So you talk about like water going through pipes and water traveling, let's say water traveling through here would go faster than going over here. That's called fluid dynamics, how fast water travels, like a hose. You spray a hose, and have you ever put your thumb on the front of the hose, and all of a sudden it's like a lot stronger, a lot faster? That's called fluid dynamics. You need to know for electromagnetics and electric engineering. So like these right here, motherboards, system boards, electronics. You also need to know for quantum mechanics. Yeah, I'm talking about quantum physics, more complicated stuff, and signal analysis. Yeah, so signal analysis, how do signals transfer? Like talking about radio waves, all kinds of signals. How do they transfer? They use imaginary numbers. So it has a lot of applications, but a lot of you guys will not use it, you know, if you don't actually go into higher level math. But it's still interesting to see, and we're just gonna touch the tip of the iceberg and just talk a little bit about it. We're not going into depth about how many things you could use it for. So we're just going to talk about simple things. We're just going to talk about properties. And we're only talking about like maybe 4 properties today. How to add, subtract, multiply, divide, and simplify. I don't know how many that is, but I think it was 4 or 5. Add, subtract. Imaginary numbers look in the form like this. Usually it's like 3 plus 2i. You put the real first, 3, then plus 2i. This is the imaginary part right here. This is the real part. 3 is real, 2i is imaginary. So how do you add and subtract that? You do exactly the same thing. You treat it kind of like a variable. It has the same properties as variables. Plus 5 minus 6i. You combine real with real, imaginary with imaginary. 3 and 5 make 8. 2i and negative 6i make a negative 4i. Can you combine real and imaginary? No. That's weird. You don't want to be real imaginary, right? So real with real, imaginary with imaginary. What if it's a little more complicated, like 5 minus 2i minus 6 minus 4i? Same thing. If it was a variable, what would you do here as a variable? You would take this negative and distribute this in. 5 minus 2i minus 6 plus 4i. And same thing, combine like terms. Real with real, imaginary with imaginary. When you're writing a complex number, you want to write real first, because real is more important, then imaginary. So that's how you add and subtract. Very simple, not too complicated. Let's talk about multiply. So how do you multiply imaginary numbers? Same thing you do with variables. Take a look. Same thing you would do with variables. Let's say we had a 2i times 5 minus 6i. Same thing, but take a look. Multiply here, that becomes 10i. Multiply here, that becomes a negative 12i squared. Okay, very good. A couple things you want to know here. First of all, what's I? Good, imaginary. You remember it from a couple slides ago. What's I squared? Negative 1. Let's write that down. I is imaginary. I squared is negative 1. A couple things you know. This is an I. This is an I squared. When you're dealing with imaginary, you never want anything more than an I. Think about it. Like, let's say you had a daughter, and your daughter comes up to you and goes like, "Oh, I have imaginary friend." You're like, "Oh, that's so cute. That's nice, right?" What if your daughter comes up to you and goes, "Oh, I have 10 imaginary friends." You're like, okay, time to see doctor, right? You don't want to have more than one imaginary. So right here, too many imaginary. I squared means I times I, too many imaginary. So simplify it. Fix it. This becomes 10i. This becomes minus 12. What's I squared? I squared is negative 1. Remember that? I squared is negative 1. I squared is negative 1. So take out the I squared, replace it with negative 1. So remember, your final answer should not have anything more than one I. That will be 10i. This is negative 1 times negative 12 will be a positive 12. And you're done. But hold on. Real with real, imaginary with imaginary. This will be 12 real first plus 10i. Remember, real is more important. Make sure you put the real first in your final answer. Alright, so far so good? Let's do a more complicated multiplying problem. Take a look. Let's say I say multiply something like this. 2 plus 3i times 5 minus 2i. Multiply this. I distribute. Take a look. I distribute. Distribute, distribute. Same thing as I do with if it was a variable. 2 times 5 is 10. 2 times negative 2i is negative 4i. Other side. 3i times 5 is 15i. 3i times negative 2i is negative 6i squared. Sound good? Combine like terms. These two are the similar, so it becomes 10 minus plus 11i minus 6i squared. Is that good enough for an answer? No, it's not. Good, you caught it. I squared right here. Remember, we can't have more than one I, so fix it. 10 plus 11i. What do you know about I? What's I? Imaginary. Good. What's I squared? Negative 1. So minus 6. Take out that I, put in a negative 1. This becomes 10 plus 11i plus 6, which is going to be 16 plus 11i. Real first, and then imaginary. How do you guys feel so far? Alright, good. Adding, subtracting, multiplying. I'll talk about divide tomorrow, but before I'm done, we'll leave this off for tomorrow. But I want to talk about simplifying. What if you have many, many, many imaginaries? What if you had like I to the 10th power? What does that really mean? That really means I times 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 I. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means I times I times I times I times 10 times. That's a lot of I's. But hold on, what's I? I is imaginary. What's I squared? I squared is negative 1. I have 10 here, 10 imaginary friends. So that's way too much. Simplify it. That means every 2 i's or I squared is negative 1. So this right here is an I squared. That right there is a negative 1. You see that? Times. This right here is an I squared. That right there is a negative 1. Times. This right here is an I squared. That right there is a negative 1. Times. This right here is an I squared. That right there is a negative 1. Times. This right here is an I squared. That right there is times a negative 1. That means negative 1 times negative 1 times negative 1 times negative 1 times negative 1. Negative 1 5 times, which is negative 1. That's how you simplify multiple i's. Let's take a look. I'm going to show you how to do this another way. Because as the numbers get bigger and bigger, like let's say I to the 1,000 power or 500 power, you don't want to write that 500 times or 1,000 times. That's way too much. So take a look. I squared. That's what we really care about, because I squared is negative 1. How many I squares are in 10? How many pairs of i's if I have 10 of them total? There's going to be 5 pairs. So this is like I squared 5 times. Look at that. Isn't this I squared 5 times? You guys see that? I squared 5 times. This means negative 1, because I squared is negative 1 to the 5th power. Negative 1 to the 5th power is negative 1 times negative 1 times negative 1 times negative 1 times negative 1 5 times, which is negative 1. How do you feel about that? Alright, we're going to practice more in class, but hopefully you got a good grasp on that. Alright, that's it. Have a great day, and I'll see you tomorrow.